Alpha Centauri. Could we find life on planets with two suns? Let's dive into the fascinating world of Alpha Centauri, the closest star system to our own solar system. Located just 4.37 light-years away, Alpha Centauri is a triple star system consisting of two main stars, Alpha Centauri A and Alpha Centauri B, which form a binary pair, and a third star, Proxima Centauri, orbiting much farther out. Now let's talk about the stars themselves. Alpha Centauri A is a G-type main sequence star, much like our own Sun. It's about 1.1 times the mass of our Sun and shines with 1.5 times its luminosity. On the other hand, Alpha Centauri B, a K-type main sequence star, is a bit smaller and cooler. It has about 0.9 times the mass of the Sun and only half its luminosity. The binary nature of these stars creates a unique environment where any potential planets might experience dual sunsets and variable solar influences. So, what about the potential for habitable planets? While no confirmed planets have been discovered around Alpha Centauri A and B so far, the system's similarity to our own makes it an exciting target in the search for Earth-like planets. If such planets exist, they would likely be found in the habitable zone, a region where conditions are just right for liquid water and potentially life. The habitable zone around Alpha Centauri A would be located between approximately 1.1 to 1.7 astronomical units from the star, similar to where Earth orbits our Sun. For Alpha Centauri B, the habitable zone is closer, between 0.7 to 1.2 astronomical units due to its lower luminosity. Any habitable planet in these zones would need a stable atmosphere to support life. The interplay between the two stars could lead to complex climate systems with varying solar radiation patterns due to the binary orbits. Picture this. Planets in the habitable zone of either star might feature a range of environments from lush, Earth-like conditions to arid deserts. The presence of two suns could result in unique lighting conditions, with variable light intensities and colors throughout the day. Life on such planets could adapt in various fascinating ways. For instance, phototrophic organisms might evolve to harness energy from both stars, potentially with a broader spectrum of photosynthetic pigments to capture different wavelengths of light. Nocturnal life forms might thrive during the cooler, dimmer periods when one or both stars are not directly overhead. And with the higher temperatures from dual star exposure, life forms could develop advanced thermoregulation capabilities or reflective surfaces to minimize heat absorption. Imagine standing on a serene landscape with two suns setting on the horizon, one larger and brighter, the other smaller and cooler. The sky painted with a gradient of colors reflecting the unique spectral qualities of the two stars. This is just one of the many incredible possibilities that make Alpha Centauri a prime candidate for the search for extraterrestrial life. Thanks for joining me on this cosmic journey. If you enjoyed this dive into the Alpha Centauri system, make sure to like and subscribe for more space explorations. Until next time, keep looking up.